Good morning, my YouTube viewers. In this video, what we're going to be talking about is logistic regression, which is another measure of association. And so basically, you have logistic regression and linear regression that are part of measures of association. And these two models were part of statistics before they became part of machine learning. So you may be familiar with logistic regression and linear regression in machine learning, but they were part of statistics before they were put into machine learning. So what we're going to do is we're going to write a program to prove logistic regression in Python. But before we write the program in Python, what we have to do is we have to import the libraries that we're going to need to execute the program. So the first thing that we're going to import is NumPy as NP. NumPy is a numeric library that also creates NumPy arrays and also creates distributions. And it performs numeric calculations. And then we're going to import pandas as PD. And pandas is a data processing library that creates data frames and series. And then the next thing we're going to do is we're going to import sklearn and a number of the functions out of sklearn, such as train test split, logistic regression, accuracy score, and confusion metrics. So sklearn is Python's machine learning library. Train test split is going to split the data set up into a training and validation sets. Logistic regression is the model that we're going to use, that it's going to convert the output to either a 1 or a 0. And accuracy score is going to compare the accuracy of the predicted values against the true values. And the confusion matrix is going to tell you how many of the predictions were true and how many of them were not true. So the first thing that we're going to do after we import the libraries is we're going to create a small data set. So this is going to be features data equals, and it's going to be a data frame. So features 1 is a list from 2 to 19. Feature 2 is a list from 1 to 20. And then you have your target, which is going to be 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And then we're going to convert the dictionary that we have created into a data frame using pandas. And now what we're going to do after we've converted the data into a data frame, what we're going to do is we're going to define our x and our y variables. So your x variable is your independent variable, and feature 1 and feature 2 are going to comprise the x variable. And the y variable is the dependent variable, and that's going to be your target. And now we're going to use train test split to split the x and y variables into training and testing sets. So the test size is going to be 30%, and you're going to have x train, x test, y train, y test. And now what we're going to do is we're going to define the model. So the model equals logistic regression dot fit x train, y train. So that's going to be your model. And then we're going to predict upon the test set. So ypred equals model.predict x test. And then we're going to evaluate the model. So accuracy equals accuracy score, brackets, y test, comma, ypred. And conf matrix equals confusion matrix, brackets, y test, comma, ypred. And then we're going to print the accuracy and the confusion matrix. So ypred is going to be 1, 0, 1. and accuracy is going to be 66.67%. And the matrix is, you've got 1 correct. So you've got 1 correct. So 1 on number 1. And then you've got 1 on 0. You've got 1 on 0, and that's correct. And then you've got 1 on 1, and it's incorrect. It should have been 0. And then you got 0 on 0, which was false, which was correct. But you had 1 on 1, which was correct as well. So what's that saying is the zeros were correct, but one of the ones was correct and one of the ones wasn't correct. And that's what it's saying. So if we come over here, the Y-pred was 101. And the target was 001. So what it should have been is it should have been 001. But what you got instead was 101. So you had 1 on a 0. You had 1 on a 1 when it should have been a 0. But then you had 1 on 1 when it should have been a 1. And so that's your confusion matrix. And so that's why they call it a confusion matrix, because it can be confusing trying to read it. But you should have had 2 zeros over here. It should have been a 2 0 and a 0 1 and a 0 1 and a 1 1. So you only had 66.67% accuracy. So that concludes this video. The next video we're going to be talking about probability theory, and I hope that you decide to watch those videos in that regard.